Okay, members, thank you for coming back. Now we are going to, let us make notes about the atmospheric temperature here. So I've written the definition. So it depends on, so we can say factors that affect atmospheric temperature. What are those factors that affect atmospheric temperature? Okay, so there are very many. So one of them is the heat from the what? Heat from the sun. Brackets, the solar what? The solar radiation. Okay, the other one is the humidity. And the last way is altitude. Altitude, heat from the sun. The other one is the solar what? Sorry, the change in season, the difference in the variation in the season. Variation in the season. Okay. Season. So there are some variations in the season. For example, you may have Uganda. Do we have winter? Do you have winter in Uganda? And the other one is relief. What's relief? So heat from the sun, humidity, altitude, variation in seasons, and relief. And you should be able to explain those 5 things the same way how I've explained them to you. Okay? So those are the factors that affect the atmospheric temperature. All right, so they're saying that the amount of ground level atmospheric temperature ranges depends on several factors. So this is for the atmospheric temperature. Now, how about the amount of the ground level atmospheric temperature? This, in other words, here what they want you to understand is that the ground level atmospheric temperature ranges, they are talking about the temperature that is along the Earth's surface. What affects the temperature? What causes a change in the temperatures along the surface of the Earth? That's why they call it ground level. So what causes the changes of the ground level atmospheric temperature changes? What causes it? So there are several factors that will make the surface of the Earth to have different temperatures. One of them is the average temperature. What do they mean by the average temperature? The average temperature. The temperature maybe on a particular day. That's the average temperature. Then the average humidity. the regime of winds. Now here they're using very the regime of winds. Maybe they would have said the regime of winds. Or they would have said maybe the amount of winds, or the level of, or the strength of the winds, something like that. So these winds also affect the surface temperatures. The wind that blows over the surface of the earth affects the surface temperatures. When you study heat deep and we look at, we shall be able to look at maybe evaporation at time t, you'll find that wind is one of the factors that maybe causes cooling of a certain object or a surface of an object. So when air is blowing, let's say during morning hours, you expect the day to be very cold, especially if you are next to the lake. Yeah? Air will blow from the lake towards the land, and that air or that wind that is blowing from the lake, it is very cold, very cold. So if these kind of winds are blowing over the surface of the earth, it means that now this surface of the earth will become colder and colder and colder. So this will cause a change in the surface or in the ground level atmospheric what? Temperature. Then the other one is the proximity to large bodies of water. So let us write those factors there. So we are looking at the ground level. In other words, the question is there. The question is that, or the heading is that, causes of ground level atmospheric. Let's observe this situation. What causes the temperature changes on the ground level? What causes them? One is the average what? The average temperature. One of them is the average temperature. So here you say that you can say that the temperature of the day causes the temperature of the day causes the Earth's surface to have a variation in the quantities of heat from the sun. Okay, so there will be a variation in the quantities of heat or heat amounts that are received from the earth due to the average temperature, and this will cause the changes in the ground level atmospheric temperature. The other one is the average humidity. Average humidity. So high levels of humidity, high levels of humidity lead to a low ground level atmospheric temperature, while low humidity leads to high ground level atmospheric temperature. Okay, So if the humidity is low, then you expect the temperatures to be very high. But if the humidity is high, you expect the temperatures to be very what? Very low. Then the other one is regime of winds. Regime of what? Regime of winds. So you can say that fast moving winds over the Earth's surface leads to a low temperature, since the heat is carried away. Okay. So those fast moving winds over the Earth's surface lead to a low temperature since the heat is carried away. So they carry away the heat, and this will lead to low temperatures over the Earth's what? The Earth's surface. And the reverse is true. If we have low moving winds, then it means that the temperatures are going to increase because those winds are not carrying away the heat. Then the other one is proximity. Proximity to large what? Large bodies. Proximity to large bodies, e.g. waters and seas. E.g. waters or water bodies. E.g. proximity to large bodies of water. You can say waters to mean lakes and what? Large bodies. Sea. Sea. Okay. Okay. So you should know that regions that are next to the water bodies are cooler. So regions next to water bodies are cooler than those far from them. So this means that those regions that are near to the water bodies are going to have high temperature. Are going to have a low temperature compared to the regions that are far away from them. So this leads to a low temperature near the water bodies compared to those regions away from. Okay. So here they are giving explanation. They're saying that it is hotter near the Earth's surface because heat from the sun warms this air. As the altitude increases, the number of air molecules decreases. Thus, the average kinetic energy also decreases. However, temperature increases with altitude above a certain height because increasing amounts of ozone. So here, what they are telling you is that when the earth hits the earth, when the sun hits the earth becomes hotter and it warms up the earth's surface. So even the air that is above the earth's surface becomes warmer and warmer. So as the altitude increases, the number of molecules reduce. So you should know that at a higher altitude, the air molecules or the amounts of air keep on reducing and reducing as you move to high altitudes. And that's why sometimes people who are traveling in airplanes have to get air masks, oxygen masks, so that they can have oxygen. Otherwise, at a high altitude, the air particles there are few, or the air quantity at a high altitude is is of small amounts. Why is it of small amounts? The reason is because of the atmospheric pressure, which we shall study later on. So it is that atmospheric pressure that causes the air particles at a high altitude to be of low quantity compared to those at a low altitude. So as the sun hits the earth, since the earth is at a low altitude, it means that the air even that is above the earth, that is slightly above the earth, this surface is going to be heated up and it becomes warmer. Becomes warmer. Now that's why at a high altitude, people on a low altitude are going to feel a lot of heat compared to those people who are on a mountain. Because people on a mountain, they are at a high altitude, and at a high altitude, the number of molecules which are there decrease, or the number of molecules decreases, and this leads to a decrease in the average kinetic energy. So if the air molecules cannot move, it means that if the air molecules are very few, then it means that also the kinetic energy of those air particles is going to reduce. Because remember, all this, you should be able to connect to your physics. Remember, we looked at Brownian motion, where I would say that air particles move randomly or constantly in a random manner, or a random motion, colliding with one another. So it means that if the air particles at a higher mountain, they are few, that means that even the number of collisions will reduce. So this also leads to a reduction in kinetic energy. And for a physicist, if they ask you what is temperature, you know that temperature is the average kinetic energy of an object. So if the kinetic energy of an object reduces, then it means that also the temperature of that object has reduced. So that's why they are saying that at a high altitude, the number of molecules are few and the kinetic energy decreases, which reduces the temperature at a high altitude, compared to the temperature at a low altitude. Are we together? Members, are we together?
Yes.
Yeah, I was explaining this. So if someone asks you, explain why, I think let me write that one as a question. Explain why. You can write it as a question and write that explanation. Explain why. Uh, explain why it feels colder at a high altitude than at a lower altitude. Why does it feel colder at a high altitude than at a low altitude? If someone asks you to explain that, what should you write? So you can say that it is warmer at a low altitude since the sun hits the earth's surface. To stop, then you say since the earth is the earth's surface and air above it becomes warmer. Okay, becomes warmer. Then that's the reason why at a low altitude it is warm. Then let us write the reason why at a high altitude it is cold. So this one will explain why it is warm, or it feels warmer at a low altitude. Now let us write the reason why it feels colder at a high altitude. So you should know this, that as the altitude increases, as the altitude increases, the number of molecules decreases. The number of molecules does what? Decreases. Thus, a decrease in kinetic what? Kinetic energy. That's a decrease in kinetic energy. So if those molecules, their kinetic energy decreases, then therefore, the temperature at a high altitude reduces due to decrease in kinetic what? Hence, one feeling cold. So therefore, the temperature at a high altitude reduces due to the decrease in kinetic energy. Hence, one feeling what? Feeling cold. So that's the reason why someone will feel cold at a high altitude, and this one will give the reason why someone feels warm at a low altitude. Is it okay? So members, when you look at Uganda, Kasese and Gulu, which one is at a high altitude? Yes, which one is at a high altitude? Kasese and Gulu. Who knows? Now you have understood which one is at a high altitude. Hey, I'm asking, someone is asking, as in, I'm asking, when you look at Uganda, the relief of Uganda or the terrain of Uganda, we have Rwenzori up there. It is very, okay, Kasese, people who stay in Chisoro there, Kasese, it is very cold. Now, people who stay in Gulu, people who stay in the side of Southern Sudan, it is very hot. Now, do you know the region which is on a high altitude now? Which region is on a high altitude? I'm asking you. Which region is on a high altitude? Are people there, or they are just on and they are watching TV? Stuart? Stuart is even snoring. Stuart? Kathy?
Yes, teacher, pardon.
My question is that, can you tell me the regions? Can you tell me which region is on a high altitude? Gulu and Kasese, which one is on a high altitude?
Teacher, Gulu.
Gulu is on a high altitude because it is in the north. Yeah? Is it because it is in the north? Okay. Stuart.
I think it's Kasese.
It's Kasese. Okay, let me give you
Because
another
it's
scenario.
mountainous.
Okay, Lake Victoria and Gulu, the region, people in Kalangala. Do you know Kalangala?
Yes.
Kalangala. Kalangala and the Southern Sudan. Let me use Southern Sudan. Kalangala and Southern Sudan. Which one is on a high altitude?
Angala.
Kalangala is on a high altitude.
Yes.
Okay. Let me hear. That is Stuart. How about you, Sean?
I would go with Southern Sudan.
Southern Sudan is on a high altitude. Okay. How about Pav?
It's Kalangala.
Kalangala is on a high altitude.
Yes.
Okay. Ruth. Okay. Let me ask. Pav, you give us the reason why we are saying Kalangala.
Kalangala is in Lake Victoria. So now it is near the equator. Yes, and near the equator, the place is a bit. Yeah, I could say it's like a hump. I could say so. It is on the high altitude because it is near the equator. That's the reason.
No.
A bit near than the Southern Sudan.
Okay,
Yeah.
Stuart. Just
Yeah.
from what we have
I
studied,
said
the answer is from what we have studied. Yes.
may I think because the water from Lake Victoria flows north.
Yeah, flows north. Okay.
Flows towards South Sudan.
That is okay. So it means that Kalangala is on a high altitude, isn't it?
Yes.
Yes, good. But I want you to look at the temperatures. Have you ever been to Southern Sudan? Has anyone ever been to Southern
No.
Sudan?
Yes.
Hope has ever been there. Hope, does it rain in Southern Sudan?
Now it's hot.
It is very hot, isn't it? So here I've said that as the altitude, I've said that it is warmer at a low altitude since the sun hits the earth's surface and the air above it becomes warm. So it means that all those regions that are hot, all those regions that are warm, they are at a low altitude. Are we together? If you want to compare,
Yes.
you compare those regions with another region, so you look at the altitude. So it means that now Southern Sudan is at a low altitude compared to Kalangala. Because in Kalangala, even right now, I think it is raining. It is raining. So it means that for them, they have low temperatures. They have low temperatures because they are at a high altitude. I wanted to use Kasese. Even the other thing is that water flows from Lake Victoria to the north. It means that water comes from something that is on a high altitude and then starts flowing. So it cannot flow from low altitude to high. No, it flows from high altitude to low what? To low altitude. So that one also is an explanation, but that is a geography explanation. But the physics explanation is that those areas that are at a low altitude receive a lot of heat from the sun because the Earth's surface receives that heat and starts radiating the heat, warming up the air, and the place becomes very hot compared to those areas that are at a low altitude. Now, when you go to Umbari, where there is Mountain Elgon, it is very cold there. The reason is that at Mountain Elgon, they are at a high altitude and we expect very low temperatures there. Okay. All right. So they have given us a summary. They are saying this chapter, you have learned the differences between heat and the temperature. Can we go through this? Do you know what heat is and the temperature? Members, do you know what heat is and temperature? Heat and temperature. So temperature, we looked at temperature. Mr. Richard told you this temperature, the average kinetic energy of the particles. Or for you, are defining the degree of hotness and what that is P2 definition. So it is just the average, the average kinetic energy of the molecules. That is what we call the temperature. Are we together? And what is heat? What is heat? Who can define for us heat? What is heat? Okay, members, are you revising? Are you revising, Pav? Are you revising?
Yes.
Heat is a form of energy.
Transferred from one
Is
point
the
to
form of
another
energy that makes things hotter.
The form of energy, no?
Is a form of
Let us hear Hope. Hope has a good answer. Hope, what is heat?
It is a form of energy transferred from one point to another due to temperature differences between them.
Very good. Heat is the form of energy transferred from one point to another due to the temperature differences between what? Between them. Thank you very much, Hope. Okay. And now we looked at how temperature scales can be established. So you must know the lower fixed point and the upper fixed point. The conversion of temperature changing from Kelvin to Celsius and also changing from Celsius to Kelvin. What do you do if you want to change from Celsius to Kelvin?
Subtract.
If you want to change from Celsius to Kelvin, you do what? You subtract or you add? Change 37 degrees Celsius to Kelvin. What do you do? Yeah. If you want to get in Kelvin, you get the degrees Celsius, then plus 270 what? 273, isn't it? So you get 37, then plus 273, and you get 300 Kelvin. That's how you change from Kelvin. I mean, from degrees Celsius to what? To Kelvin, you add. Okay. If we're changing from Kelvin to degrees Celsius, then you have to subtract. Degrees Celsius have to subtract. Okay, you have to subtract. So if you have, let's say, 473 Kelvin, and you want to change it to degrees Celsius, then you're going to find the degrees Celsius as the temperature in Kelvin, then minus the 273. Okay, and from there you get 473 minus 273, and you get what? You get 200.
Yes.
You get 200 degrees Celsius. So we also looked at that. Qualities of mercury, alcohol, and thermometric liquids. We looked at this with Teacher Richard. Those were the thermometric liquids. Mercury, alcohol. We say that mercury is used because it is opaque. Mercury is used because it expands uniformly. Mercury is used because it is a good conductor of heat. Or mercury is used because it does not wet glass. So all those were the properties of mercury and the reason why mercury is used in a thermometer. And we looked at the disadvantages of alcohol and water. We say that alcohol, for it sticks on the glass. Also, water sticks on the glass. They are colorless and they are not opaque, so they cannot be seen easily. And then we say that they do not expand uniformly, especially water does not expand uniformly. That's why it is not used in thermometers. But we said that alcohol also has an advantage over mercury. Alcohol can be used to measure very, very low temperatures. It is suitable for measuring very low temperatures, whereas mercury, it is suitable for measuring very high temperatures. Did you look at that with Teacher Richard? Yes? Okay, you can add them there. I've said that mercury is suitable for measuring very high temperatures. You can add it there. Mercury is suitable for measuring very high temperatures. And then alcohol is suitable for measuring very low temperatures. Very low temperatures. Okay, we have seen the construction of a clinical thermometer, and now we have seen the causes and effects of the daily variation of atmospheric temperature. We have looked at the rotation of the earth and we gave the reasons. So we said that the radiation from the sun, we also looked at the relief, we looked at the humidity. All those give rise to the variation of the atmospheric temperature. Are we together? Members, are you eating? Sean.
We are
Yes,
not eating.
Sean, you have started eating. Don't worry, we are about to finish. So we have the activity of integration. So they're saying the daily activity at school are being affected by the weather variation, especially temperature. As a physics student, you have been asked to prepare a temperature chart and a message below how the chart will be useful. Now, do you have a thermometer at home?
No.
No, we don't have.
No.
Are you going to buy one?
No. No, we don't have the money to buy it.
Okay, when you come back here at school, we shall do this experiment. Now, in your books, are we together? In your books, you write
Yes.
it what?
Yes.
It transfers.
Yes.
So we shall start from here next week. Are we together?
Yes.
But tomorrow when we meet, we are going to look at this one here. We're going to look at this. We finished this, we finished that, we finished that, we finished this. Ruben, where have you been? First, you've been studying, yeah? We finished this, we finished this, so we are going to look at, we finished this. So Ruben, where have you been? Even Ruth.
Yes.
These days you are off and on. Why? So we are going to look at this part here. Tomorrow, we are going to look at the capillarity. No, before capillarity, we are going to look at surface tension. So we are going to just look at this meniscus and we look at surface tension. Surface tension, look at surface tension. Tomorrow we are finishing this chapter here. Surface tension and capillarity. And that will be the end of that. So here it is temperature. You see, I've now finished temperature. Yeah? So we are going to heat transfer. So even tomorrow we are finishing this and we shall look at other new topics. So members.
Yes.
Yes.
Thank you for coming and studying.
You're welcome.
Hey, may God bless you.
Also, thank you for teaching.
All right, may God bless you and your parents.
God bless you too.
We meet tomorrow. Have a nice appetite.